We'll now turn to Chapter 22, which is the second of two chapters on exotic options. And the focus of this chapter will be on one particular kind of exotic option, although the chapter itself covers a number. There's only one of the categories of options considered in the chapter that will be on the examination that we're preparing for. All or nothing options will be the focus of this discussion. So we have a simple all or nothing option ultimately can be used as a building block to develop more complex options. And that's really the orientation of this chapter, is to introduce all or nothing options and then to see how they're used as building blocks. We're only going to focus on the initial building block itself, the all or nothing, and not cover the other varieties. We'll assume the familiar process of geometric Brownian motion for the stock price. Alpha is, as usual, the total return in the real world, and delta is the continuous dividend rate. And so alpha minus delta is the capital gain or loss in stock price per share. Recall these D1 and D2 were the notations from the Black-Scholes formulas, which allowed you, and these were the values that you evaluated the normal distribution function at in order to, with the value of the option, with the value of the stock and with the value of the strike price, could then come up with a call or a put price. So a simple all or nothing option pays the holder of the option, the long position, if a particular event occurs. And the only question is, what gets paid if that event occurs? And there are two types. It could be a discrete amount of cash, and in this chapter we'll assume $1, or it could be a share. So a simple all or nothing option, if an event happens, which will be dependent on share prices, if that event happens, either a unit of cash will be paid or the stock will be paid. A cash or nothing option is an option where a unit of cash is paid. So a cash call pays $1 if the stock price at expiry exceeds the strike K. So you can think of it as it has the same payoff as an event. The payoffs of this are as a typical call, and that is that when stock prices exceed K, a payment is made. So that's a typical call. The difference is that a cash or nothing call pays $1, whereas a vanilla call would pay the difference between the stock price and the strike. A cash or nothing put is identical in the sense that a payment is made when stock prices are below the strike. For a vanilla put, the investor would get a payment of the amount by which the stock price is below the strike at expiry, whereas for this cash put, this cash or nothing put option, the investor gets $1 if the stock price at expiry is below K. Asset or nothing options are identical to cash or nothing options, but rather than a payment of $1 being made, a payment of one share of stock is made. So a call pays S, which is a share of stock, if the stock price is larger than the strike, whereas similarly an asset put will pay one share of stock if the stock price is below the strike price. And you'll notice that we have, in both cases, prices for these options, which may look like pieces of the Black-Scholes formula. And we'll get to that in a moment. And let's go back and now look at those prices more carefully. Notice that the cash call, this is the option that pays $1 when prices are above K. This looks like a piece of the Black-Scholes call formula. And similarly, the cash put the price of a cash put looks like a piece of the Black-Scholes put formula. On the asset or nothing options, we see the same phenomenon, that the asset call looks like another piece of the Black-Scholes call formula, and an asset put looks like the other piece of the Black-Scholes put formula. And why is that?